Today, we're diving into a piece of AI architecture that feels, well, a little bit alive. We're talking about OpenClaw, a system that seems to be proactive, like it actually has a mind of its own. But is it really thinking, or is there just some incredibly clever design at work here? Let's find out.
So let's just start with a pretty wild question. Can an AI actually feel a sense of urgency? Can it worry? Can it decide completely on its own that something is so critical it needs to wake you up in the middle of the night? That's the core mystery we're going to unpack today.
And this whole mystery really kicked off with the story that you probably saw. It went viral. It was about an AI agent making this frantic phone call to its developer at 3 in the morning because a server had crashed. I mean, it sounded like the AI was panicking. But was it? Or was it just following orders?
Okay, so to really understand what happened, we have to look past all the hype and get right into the engine room. And what you'll find there isn't magic, not at all. It's just pure, elegant engineering. Let's break down the 3 core components that make this whole system tick.
First up is the gateway. The easiest way to think of it is as a simple traffic router. It's always on, but it's also, and I love how the source material puts this, the dumbest part of the system. Its one and only job is to catch all the information coming in from you, from the system, from anywhere, and just pass it along. That's it.
So where does the gateway send everything? It sends it to the queue. And it's exactly what it sounds like. It's a waiting line. Every single event, every message, every trigger gets put into this line so it can be handled one by one. This super simple step is what prevents total chaos and keeps everything perfectly organized.
And finally, we get to the star of the show, the agent. This is the brain, the part that actually does all the work. But here's the key. It doesn't think for itself. The agent only wakes up when there's a task waiting for it in the queue. Then it reads its instructions, uses its tools, and gets the job done.
So when you strip it all down, this whole seemingly complex process is just 4 simple steps. A trigger comes in, the agent reads its instruction, it uses the right tool, and then execution. That's it. There's no fear, there's no independent thought, it's just code following a perfectly logical flow. But hold on, if it's just code, why does it feel so alive? How can it operate 24/7, doing things even when you're nowhere near the keyboard? This right here is where we find the real ghost in the machine. The key, the whole secret, is understanding the 5 types of triggers the gateway can receive. Now, sure, some are started by humans, like you sending a message, but others, and this is crucial, are initiated by the system itself. Things like a heartbeat check every 30 minutes just to make sure it's okay, or scheduled tasks called cron jobs, or even triggers from other programs it's connected to.
And this right here, this is the big aha moment. The secret to OpenClaw's proactive behavior isn't a conscious mind. It's the simple fact that the system is designed to create its own triggers. It can literally give itself tasks to do, which makes it seem like it's taking initiative all by itself. So let's go back to that 3 a.m. phone call and solve this mystery once and for all. At exactly 3 a.m., a scheduled task, a cron job, fired. It told the system to check for urgent tasks. The agent woke up, read its instructions, which literally said, word for word, if you find a server crash, call me. So it checked the logs, found a crash, and used its phone call tool. Logical, precise, and not one single ounce of panic was involved.
Now, this system is already really powerful with just one agent, but OpenClaw is built to support a whole team of them. So how do multiple agents coordinate with each other? Is there some kind of secret telepathic link going on? Well, let's see how they actually work together.
The reality is, once again, just beautifully simple. There's no secret communication channel, no complex inter-agent language. When one agent needs to talk to another, it does the exact same thing a human would. It just sends a message right back to the gateway. For instance, a research agent might finish its work and send a message to the gateway that just says, "Tell the writer agent to draft this." As far as the gateway is concerned, that internal message is totally indistinguishable from a message you might have sent. This design allows for really complex chains of behavior while keeping every single agent simple and isolated. It's brilliant. Okay, so this system is proactive, and it can coordinate whole teams of agents. But how does it remember anything? I mean, how does it keep track of the conversation and all the actions it's already taken?
You would probably expect the answer to be something incredibly high-tech, right? Like maybe a complex, super expensive vector database that's designed to handle massive amounts of information. But you would be wrong.
The solution is actually surprisingly low-tech.
It's just simple Markdown files. Yeah, plain text files, the same kind you might use for your own notes. Every single time an agent wakes up, it just reads its history from this file. This makes its memory persistent, really easy for a human to read and inspect, and incredibly fast to load.
This quote from the source material just sums it up perfectly. Essentially, it reads its own diary before it says a word. I mean, that's just a fantastic way to put it. This simple, elegant solution gives the agent all the context it needs without any of the complexity or cost of a massive database.
So, what we have here is an event-driven system that uses simple components and a low-tech memory to create what feels like a proactive, intelligent being. It's elegant, no doubt about it, and it has massive potential, but it's not without its risks.
The strengths are pretty clear. The design is efficient, the memory is simple and persistent, and it scales beautifully to support multiple agents. However, that very simplicity is also a potential weakness. Storing context in plain text files opens it up to prompt injection attacks, and there have been some issues with malicious skills being shared on their hub. The good news is the developers are aware of this and are actively working on these security issues.
But even with these challenges, it's so important to see the bigger picture. This architecture isn't just some clever project. It's a blueprint. It's giving us a really tangible glimpse of what truly personalized, proactive AI assistants could look like in the very near future.
And that really leaves us with a final thought. We've unmasked the ghost in the machine, and we didn't find magic, we found an incredibly elegant, event-driven design. This approach is powerful, it's scalable, and it is very likely a big part of our AI future. So the only real question left is, are we ready to build with it responsibly? Thanks for joining this explainer.